Hello, everyone, and welcome to Say It with Symbols, Investigation 3. This begins on page 46 in your textbook. Our learning targets for Investigation 3 are that we'll be able to solve linear and quadratic equations, and that we'll begin to explore systems of equations. Our ACES questions for 3.1 are numbers 2, 4 through 7, and 37 and 38. As we get started here on page 46, we talk about solving equations and that a problem often requires finding solutions to equations. In previous units, we developed strategies for solving linear and quadratic equations, but in this investigation, we're going to use those properties of real numbers to extend these strategies that we've already learned about in our past units. Selling greeting cards 3.1 to help us solve linear equations, and it gives you a little example on page 46 that it says the steps below show one way to involve 100 plus 4x equals 25 plus 7x, and we want to solve for x. Well, if we think back to our properties of equality that we used in moving straight ahead, it tells us that we can add or subtract the same quantity from each side of an equation to write an equivalent equation, or we can multiply or divide each side of an equation by the same non-zero quantity to write an equivalent equation. All this means is whatever you do to one side of the equation, you must do to the other. And what they're asking you to do here, and what they're showing you is asking you what is done each step and why. Well, when we solve equations, we need to get all our variables on one side and all our products on the other. So if we have 100 plus 4x equals 25 plus 7x, we have variables on both sides. So the first step they're going to do is take away 4x so that it's no longer on this side. But if we do it to this side of the equation, we must also do it to this side of the equation. And then we're left with 100 minus 25 plus 3x. Well, now that we don't have variables on this side anymore, we just have them here. Now we're going to take our 25 and move it to the other side of the equation. In order to do that, we must subtract 25 from both sides of the equation. So if we subtract 25 from this side, 25 minus 25 is 0, so it gets rid of that. And 100 minus 25 gets 75. So now we're left with 75 equals 3x. To find out what 1x equals, we need to divide both sides of the equation by 3. And so if we do it to one side, we must do it to the other. 3 divided by 3 here gives you 1x, and 75 divided by 3 gives you 25. So 1x equals 25. Now you can use these properties as well as distributive and commutative properties to solve these equations as well. So I want you to do A and C, and to give you a little heads up on A, let's watch a quick video.
The sale is about to start, and I haven't seen all the cards yet. What does the Valentine's Day card look like?
For Valentine's Day, we have a card featuring Earl and Pearl Squirrel. Here's one.
Let's see. We should be okay. Valentine's Day cards always sell. Have you seen the Chuck the Duck card for Administrative Professionals Day?
I don't know if we should have bought all our cards from a place called the Crazy Card Company.
We printed so many cards. That's going to be most of our operating cost right there.
We need to start selling cards to bring in some revenue. I wonder if we'll make a profit from this sale.
We'll make a profit if our revenue is greater than our operating costs.
So, we just need to find when our operating cost equals our revenue.
Right, that's the break-even point. But what does this equation for profit have to do with operating cost and revenue? How many boxes of cards will they need to sell to make a profit?
Okay, so we introduced a little bit of vocabulary there. They talked about operating costs. Operating costs are also known as expenses, which we have over here represented by the letter E. Revenue is also known by the term income, which we have represented by the letter I. So revenue is the same as income, and operating costs is the same as expenses. Well, to calculate your profit, you need to find out what your income minus your expenses is. If your income equals your expenses, that is break even. If your income is greater than your expenses, you get a profit. And if your income is less than your expenses, you have a loss. So they give you an equation here of P equals 5S minus 100 plus 2S. This is set up the same as our P equals I minus E. So the 5S is your I, and the 100 plus 2S is your E. I want you to go through these and be able to answer those questions. How many boxes do they sell? Use an equation to find out how many they must sell to make a $200 profit. Be able to explain what each of these terms is, and find out if this expression is the same as this expression, so you'll need to expand that out using your PEMDAS. And then for C, it gives you a number of equations here, and it wants to know what the value of x is when y is 0. So you'll set y equal to 0 for each one of these. So it'll be a 0 here. 0 equals 5 plus 2 times the quantity 3 plus 4x, so on and so forth. Solve that for each one of these. And that's it for 3.1. Again, our ACEs are numbers 2, 4 through 7, 37, and 38. Good luck, and look forward to hearing your comments and questions in class.